What's up, eco-nerdlings? In this podcast, we're going to be discussing geology, plate tectonics, and the rock cycle. So before we get started, I want you guys to write all of these questions in your journals, and as we go through the next 2 or 3 podcasts, I want to make sure that you answer each and every one of these questions in your journals. So take some time and write them down. And second set of questions, hit the pause button. All right, so let's get started. Our core case study in this unit is what is the real cost of gold? So the major gold producers in the world are China, South Africa, Australia, the United States, and Canada. So one of the largest problems with the gold mining industry is cyanide heap leaching. So what the heck is that? Well, we should all know that cyanide is a very poisonous chemical that can actually kill us, as well as many other organisms, birds, fish, any other type of mammal. So the way this works is that, gold typically isn't just pure gold laying out there for us to just take. A lot of times it's mixed in with a lot of other minerals. So for example, if it's mixed in with ore, we actually use chemical cyanide to separate the gold out from the ore. And of course, cyanide starts to leach out into the environment and can destroy many different species of fish, birds, wildlife, basically anything it comes in contact with. So the first thing we're going to be discussing are plate tectonics. So what is the study of plate tectonics? Well, plate tectonics is the theory explaining the movement of the plates and the processes that occur in their boundaries. This should be something that you guys have at least heard of at some point in time in your lives. So the Earth is made up of the core, the mantle, and the crust, and it's constantly changing as a result of the processes that are taking place at or below its surface. So the Earth's interior consists of different layers. We have our core, which is the innermost zone with a solid inner core and a molten outer core that's extremely, extremely hot, under very, very, very large amounts of heat and pressure. The mantle is solid rock with a rigid outer part called the asthenosphere, and it's melted and it's pliable rock. And then we have our crust, which is the outermost zone, and it underlies the continents. So we have 2 types of crust. We have the oceanic crust, and this actually covers about 71% of Earth. And then we have our continental crust. That's where we live. So these are the layers of the Earth. We have our core, which is our solid metal inner core, and then we have our outer core of molten metal. We have our mantle right here, and you can see it a little bit better in this cross section. And then we have our crust. And again, our crust is going to consist of the oceanic crust as well as the continental crust. And then again, here's an even littler cross section, kind of taking it a little bit more. We're going to have our mantle. We have the asthenosphere, and then we have the lithosphere. So this is another section of our Earth. So we have the mantle or the asthenosphere, and then we have the lithosphere, which is in the mantle. This is what the plates actually sit on top of and move around. We have our oceanic crust, and then we have our continental crust. And we have different formations occurring at the boundaries. We can have volcanoes, mountain chains being formed. At the oceanic crust, we have an ocean ridge that's going to be forming. Sometimes we have trenches. And so looking at another section, I wanted to show you guys the convection currents. So basically what's going on below the plates in the mantle. So we have our plates, and right here we have plate movement. We have plates separating out right now. That's going to be a divergent boundary, if you didn't know that already, at the oceanic crust. So these are the mantle convection cells. Basically, hot rises, and then as it cools, it starts to sink. So right here we have hot material rising through the mantle, comes up. As that material rises up, it starts to get a little bit cooler, and then it's going to sink. Right here it's showing you the cold dense material, again, falls back through the mantle. If we have our 2 plates colliding, one plate goes under the other. We call this a subduction zone. It gets sub, meaning under, ducted. All right, so we have a subduction that occurs. That's the plate that's going to go back down into the mantle and come back up again eventually. So it basically gets recycled, goes into the mantle, it melts, goes down, and then as it heats up, it's going to come back up again. So we have huge volumes of heated and molten rock moving around the Earth's interior, and they form those massive solid plates that move very, very slowly across the Earth's surface. The tectonic plates are basically huge rigid plates that are moved with the convection cells or currents by floating on the magma or the molten rock. So there are different types of boundaries. We have a divergent boundary, divergent. This is when plates are moving apart from each other in opposite directions. So as you can see right here, plates are moving in opposite directions away from each other. So we have convergent boundaries. So convergent, this is when plates push together by internal forces. At most of the convergent plate boundaries, the oceanic or lithospheric plate is carried downward under the island or the continent. The reason for this is that the oceanic plates are typically thicker than the continental plates. So since they're thicker, those are the ones that are going to get subducted. Earthquakes are very common here, and it also forms an ocean ridge or a mountain range. So looking here, this is going to be a convergent plate boundary. As I said, one of those gets subducted right here. This oceanic plate is being subducted underneath the continental plate. And then we have our last type of boundary, which are transform boundaries. These are when plates slide next to or past each other in opposite directions along a fracture. California, you guys probably have heard, the myth that, oh my gosh, California is eventually going to fall into the ocean. That's not going to happen. But California does fall along a large fault line, the San Andreas fault line. So one of the ways I remember all of these different types of boundaries is this little elementary thing. So I always say, divergent is dividing, convergent is colliding, and transverse slips and slides. So if that helps you, that's awesome. If you just want to get a good laugh at your weird teacher, then you got that too. All right, so we have major tectonic plates around the Earth. So I wanted to make sure you guys knew these. You might want to write these down. So we have the Juan de Fuca plate, the Pacific plate, and the Pacific plate is also going to form that Pacific Ring of Fire. We have our North American plate, the Caribbean plate, our South American plate, the Nazca plate, the Antarctic plate. We have our Anatolian plate, the Eurasian plate, African plate, the Arabian plate, the Somalian plate. We also have our China subplate, the Philippine plate, and our Indian Australian plate. So the extremely slow movements of these plates cause them to grind into one another at convergent plate boundaries, move apart at divergent plate boundaries, or slide past one another at those transform plate boundaries. So here's our same different types of plates, and I wanted you guys to look at now the key. So if you see this red color, that's going to indicate a divergent plate boundary. If you see what looks kind of like this little barbed wire black with spikes, that's going to be a convergent plate boundary. And then blues are transform faults. So you can see right here, these little black spikes kind of indicate a convergent plate boundary, so two plates will be converging there. If you see all of the red right here, that's going to be divergent plate boundaries. And then all of these blue lines are representing transform faults that are going to have one plate going in one direction and the other going in the opposite. So one of the largest plates that we're going to discuss very briefly is the Pacific plate. And the Pacific plate is off the coast of California. This is where lots of volcanoes and earthquakes occur. You're always hearing about earthquakes in California. You hear the California will fall into the ocean idea, which is obviously false. That's not going to happen. And it is also the largest plate and the location of the Ring of Fire. So all of the different types of volcanoes and earthquakes that are occurring. So right here we have our Circum-Pacific belt and then the Mediterranean belt. So right here, and then we have all of these different types of volcanoes that are forming, the islands that are forming as a result of the volcanoes. So we have Vesuvius, we have the Aleutian Islands that have formed because of that. So lots of different formations that have occurred. So the San Andreas Fault is something we just briefly mentioned, and it's an example of a transform fault. This is the huge fault in California that has, lots of discussions about it and things like that. So what are the importance of the plate movements? Well, plate movements add new land formations and boundaries. They produce mountain ranges and trenches. They also are responsible for earthquakes, volcanoes, as well as tsunamis, because when those plates move, they cause huge disruptions because those plates are so enormous themselves. So one of the processes that can occur as a result of movement of plates is a volcano. So volcanoes are what release molten rock from the Earth's interior. These are how the Aleutian Islands were formed, how the Hawaiian Islands were formed as well. So a fissure forms, magma rises up into the fissure, and then lava flows out. This is also going to be the site of primary succession because we're starting from scratch with no soil. So an example of a volcanic eruption is the eruption of Mount Pinatubo in 1991. There are many benefits of volcanic activity. Like I said, they're forming new islands, so new species are going to come in and colonize those islands. Primary succession occurs, so we have, soil starting to form after we have our pioneer species coming in, all kinds of stuff. So then one of the other geological processes that occurs are earthquakes. These are geological rock and roll events. So when two plates collide or they're slipping and sliding, earthquakes can form. Earthquakes form seismic waves. They start in the focus, where the plates are actually moving. That's the actual, plate movement that occurs. The epicenter is going to be the land that's actually above that focus, so where you actually feel it on land. And then the Richter scale is going to be a measurement of the magnitude and amplitude, or basically the devastating effects of the earthquake. Was it, very little, or was there a huge amount of damage as a result of the earthquake? So this is our Richter scale, excuse me. If it's less than 4, it's considered an insignificant earthquake. 4 to 4.9 is going to be a minor earthquake. Damaging is going to be between a 5 and a 5.9. Destructive is between a 6 and a 6.9. A major earthquake is considered a 7 to a 7.9, and a great earthquake is anything above 8.0 on the Richter scale. So the largest earthquake ever recorded occurred in Chile, and it was a 9.5 on the Richter scale, and that occurred in 1960. So this is some of the damage that occurred as a result of the earthquake. So this is a map of the United States and the risk of an earthquake occurring. So obviously, as you can see right here, the coastline of California up here is going to be at a pretty large risk of having earthquakes, and you hear about earthquakes in California all the time. Myself and you guys in my classroom, we live here, the great old state of Texas, so we have a very low risk of having earthquakes here, which I like. However, we have a higher risk of having hurricanes, so All right, moving along, we're going to move into the rock cycle now. This is the interaction of processes that change rocks from one type of rock to another. So we're going to just pick a place and start. So we're going to start with igneous rock. Basically, volcano explodes, magma falls out, and we have the creation of igneous rock. So igneous rock examples include granite, pumice, and basalt. If these igneous rocks undergo weathering, it could be chemical, biological, physical weathering, and erosion, then they get transported. So all those little fragments get transported. Then they get deposited. So we have layers. So, they get deposited, and then the next layer of it gets deposited, and then another layer and another. This is going to form sedimentary rocks, which are layered rocks. Examples of sedimentary rocks include sandstone and limestone. Now, if those rocks undergo extreme heat and pressure, they're going to get compacted, and they form what we call a metamorphic rock. Metamorphic rocks include slate, marble, gneiss, as well as quartzite. Now, if those get melted, eventually they become magma again. The magma rises up through fissures in the volcano, explodes out, lava flows out, and then we have igneous rock again. That's why we call it a cycle, because any of these rocks can be transformed from one to another. So again, if we want to look at the steps, we start right here. Just pick a corner, sedimentary rock. Again, we have slate, sandstone, and limestone. If they undergo heat and pressure, they can get turned into metamorphic rocks such as slate, marble, and quartzite. If those get melted, they become magma. Magma can cool off after it comes out of a volcano, typically as lava, and then the magma will cool off, forming igneous rocks such as granite, pumice, or basalt. These can undergo heat and pressure again, go straight back to metamorphic rocks. Or they can go and start having the process of weathering occur, erosion, then they get transported and deposited, which forms layers, which can form sedimentary rocks. Metamorphic rocks don't just have to go get melted right away. They can go straight into the weathering and everything and become sedimentary rocks. So again, anything can go into the cycle and any rock can turn into a different rock as long as the correct processes are applied to it. So we're going to talk a little bit about some of the most abundant elements. We have oxygen, most abundant element in Earth's crust. Nitrogen is the most abundant element in Earth's atmosphere. Iron is the most abundant element in the Earth's core. And then we have aluminum. This is the element that's commercially extracted from bauxite. So what are the relationships between all three of these rocks? Well, all three rocks are being recycled and converted into different types of classes. So we have our igneous, metamorphic, and sedimentary. And there are different classes that they can be characterized into. So to get an idea of what each of the classes are, igneous, metamorphic, and sedimentary, I want to make sure you guys know some of the basics about those rock types. So for igneous rocks, the description is they form the bulk of the Earth's crust. It's the main source of many non-fuel mineral resources. We have different classifications or different classes of igneous rocks. We have intrusive and extrusive. So make sure you guys write these down. Intrusive igneous rocks are formed from the solidification of magma below the ground. And then we have extrusive igneous rocks, which are formed from the solidification of lava above the ground. So examples of igneous rock include granite, pumice, basalt, diamond, tourmaline, garnet, ruby, as well as sapphires. And then we have sedimentary rocks. These are rocks formed from sediments. Most of them are formed when weathering and erosion has occurred and they erode larger rocks into small pieces that are then transported and then they're deposited into different layers, a lot of times in a body or a surface of water. So we have clastic sedimentary rocks. These are pieces that are cemented together by quartz and calcium carbonate or calcite. Examples of that are sandstone, which is basically just sand stuck together, conglomerate, which are rounded and concrete looking, and breccia, which are conglomerate but they have more angular pieces. And then we have our non-caustic sedimentary rocks. These are kind of like chemical precipitates, like limestone that precipitates out and oozes to the bottom of the ocean. This is why there's so many limestone depositions. We also have biological sediments. These are like peat and coal. And then we also have petrified wood and opalized wood. And moving along to metamorphic, this is when pre-existing rock is subjected to very, very high temperatures, which can cause it to partially melt, and then very, very high pressures, chemically active fluids, or combination of all of these. The location where this occurs is typically deep within the earth. So examples, you can have a contact metamorphism. This is when a rock that is next to a body of magma. For example, limestone under heat becomes marble through crystallization. So limestone can be turned into marble, sandstone can be turned into quartzite, and shale can be turned into hornfields or slate. And that's if it's very close to magma, which is going to give it that heat. We have dynamic metamorphism. This is when earth movement crushes or breaks rocks around a fault, and then the rocks can become very brittle. The rock and mineral grains are broken or crushed, and they may be ductile or plastic behavioral occurs. So rocks formed along fault zones are called mylonites. And we also have regional metamorphism. This occurs during mountain building, and this can also occur when great quantities of rock are subjected to intense stresses and heat. So for example, continental shelves that ram together. So progressive metamorphism is one form of rock, again, changing into another. So for example, again, we have shale, which can change into slate, which can change into schist, which can change into gneiss. We have coal, which can change into graphite, and granite, which can change into gneiss. Well, I hope you learned a lot about plate tectonics and the rock cycle and some of the geological processes that occur here on Earth. If you need to rewatch this video lecture or any others for AP Environmental Science, you can find them on my website at www.nerdlingscience.com. Well, this is the Queen Nerdling signing off for now. Stay nerdy till next time.